So welcome to your update on the COVIDENCE UK study for December 2021. My name's Adrian Martineau. I'm the Chief Investigator based here at Queen Mary University of London. So we've come to the end of another year, and I thought it'd be a good opportunity to look back on everything that the study has achieved in the last 12 months. So what did we achieve in 2021? I think perhaps the major achievement was reaching our target of 20,000 participants and closing to recruitment. The fact that we have so many participants really makes our study extremely powerful, and what it means is that we can detect even modest effects of a risk factor with statistical significance, and we can also have power to look at risk factors for breakthrough disease and responses to vaccines as well. So it does make the study really powerful, and we're really grateful to all of you for signing up and continuing to contribute to our monthly questionnaires. Just to give you a sense of how many people 20,000 people is, that's the equivalent of 4 times the capacity of the Royal Albert Hall. So it really is quite a remarkable achievement to have got so many people involved in the study, and you can see that you're part of something really big and really powerful. Not only that, but 70% of you are still regularly completing monthly questionnaires, and that's actually a really high percentage for a questionnaire-based study like this. Many studies of a similar design might be expecting to see drop-off of around half of the participants over a year into the study, but the fact that all of you participants are super engaged makes our study really strong, and again, I'm grateful for your input. Over the last year as well, we've sent out some 18,000 antibody tests. Around about half of these were sent out before the vaccine programme started, and then about another half of them were sent out afterwards. And that's provided some really critical information. The first set of data on risk factors for acquiring symptomatic and asymptomatic SARS-CoV-2 infection. And the second set of data, the post-vaccination data, has yielded really interesting insights into what the factors are that affect our response to vaccination. I'm going to touch on some of those a little bit later in the talk. We were also fortunate to get further funding from Bart's charity to support 2 new statisticians on the study, Julia Vivaldi and Florence Tideman. And having them on the team, I think, is going to make a big difference in terms of the amount of publications and analyses we can do on all the data that you're sharing with us. So our work has had impact both globally and in the UK. Here's an example of our global impact. You can see that our latest publication in Thorax earlier this month around allergies and their protective association against COVID-19 attracted interest from all over the world, here in the newspapers in India, Germany, in the United States, Russia, Indonesia. So you can see that the data that you're contributing to is actually informing scientific opinion on COVID-19 right across the world. It's also having concrete impact here in the UK. To give one particular example, our post-vaccination antibody studies have provided critical information about the relative ability of AstraZeneca versus Pfizer vaccine to induce antibody responses. We've also been able to provide critical information about the effect of the timing, and specifically the interval between first and second doses and how that can affect responses, and also new information about the impact of immunodeficiency and immunosuppressants on vaccine responses. And the pathway to impact really has been via connections with the Joint Committee on Vaccination Immunisation. That's the governmental body that advises on vaccines. Our data were forwarded to them for consideration prior to publication, so that your information from the blood spots you've given has actually contributed to the development of UK policy on vaccination. We're also contributing data to a number of national and international initiatives with the purpose really of making the maximum use and getting the maximum value out of the data that you've shared with us. So the data are completely anonymized, all of your identifying information is stripped, but then we can share our data with those of other large studies to pool data into massive biobanks, which can then be interrogated and give extra value. And a couple of the other pathways we're doing that with is through collaboration with Breathe, which is a health data research hub on respiratory infection, and that's funded by the UK government and Health Data Research UK. So in addition to these very practical impacts, our research has also yielded scientific insights. To give you a flavour of a couple of them, the protective effects of allergic disease, which we weren't expecting and which can yield perhaps new insights into host response against SARS-CoV-2. Also, the findings that we've had relating to ethnic variation in immune responses to SARS-CoV-2, again, which I'll touch on a little bit later in the presentation. So where are we going next? A new year beckons, and we have a number of ambitious plans for the study and for the data that you're sharing with us. A number of you will, yesterday I think, have received your invitation for our first wave of antibody testing following the booster jab programme. So we were successful in getting funding for that, and ethics approval for that has just come through. I'm hoping that we'll be able to report on the CoronaVic trial. This was a large randomised controlled trial involving 6,200 participants to look at whether vitamin D has protective efficacy against COVID-19. That's been held up by some data linkage issues at NHS Digital, but I'm hopeful that we'll be able to publish those results early next year. Another strand of work looks at pollution and COVID-19, and a further strand looks not just at risk factors of COVID-19, but asks the opposite question: what is the effect of COVID-19 on our mental health, our physical health, and our economic well-being? And finally, we're drilling down on a handful of people from the 10,000 who did post-vaccination antibody tests. We're drilling down and identifying people who still aren't able to make antibodies even after their booster, and doing much more detailed immunological studies to see if we can understand why that is, and that will provide new scientific insights into the factors that influence susceptibility to SARS-CoV-2 infection. So before we put our feet up for the Christmas holidays, I just wanted to take this opportunity to answer a few of the questions that you've been pinging to our inbox over recent weeks. A question we often get asked is, how common is it to get no symptoms after vaccination? Of course, the last webinar we focused on people who did get symptoms after vaccination, so I just want to clear that up. So the proportion of people who get no symptoms after either dose of vaccine for AstraZeneca is 39%, and for Pfizer is 59%. Another question we often get asked is, if I didn't get symptoms after vaccination, does that mean that I'm less likely to make antibodies? Well, you are slightly less likely, but the overall effect is that you are still very likely to get antibodies. So just to illustrate, the proportion of people who don't get any symptoms, who then do not develop antibodies, is 6% for AstraZeneca and 1% for Pfizer. In other words, if you get AstraZeneca and you don't get any symptoms, you've still got a 94% chance of making antibodies. And if you had Pfizer and you don't get symptoms, you still got a 99% chance of making antibodies. So if you didn't get symptoms after your vaccine, you shouldn't worry about whether or not you are likely to have developed an antibody response, because the overwhelming likelihood is that you did. Another question we asked is the following: I've been vaccinated, had my booster, so my risk of getting severe COVID-19 is presumably really low. So does social contact still put me at risk of infection? And this is a question that's obviously got particular relevance in the current Plan B that the government's rolling out in terms of limiting social interaction to control the Omicron variant. And so we've done an analysis looking at the risk of COVID-19 specifically in vaccinated people. And what we're finding is that even if people have had 2 jabs of either Pfizer or AstraZeneca, they are still at increased risk of getting what we call breakthrough disease. So that means getting COVID-19 despite being vaccinated. So we're seeing a 22% increase in risk per additional indoor visit per week to another household in vaccinated people, a 48% increased risk in people who live with school children, obviously who were vaccinated later in the pandemic, or for the youngest ones who haven't yet been vaccinated, and a 173% increase of breakthrough disease with household overcrowding. So that tends to suggest that even though you've been vaccinated, social interaction can still be a risk factor for getting what we call breakthrough disease, that is COVID-19 after vaccination. Another question: at the start of the pandemic, there was a lot of talk around potential benefits of nutritional supplements. Do data from COVIDENCE suggest any protective effect? Well, I refer now to this recent paper in Thorax that came out earlier this month. And to cut a long story short, we looked at multiple micronutrients to see whether they conferred protection against COVID-19, multivitamins, vitamin A, C, D, zinc, iron, probiotics, fish oil, cod liver oil, garlic, selenium. And unfortunately, we found no evidence that any of these supplements afforded any protection. Nevertheless, the vitamin D trial, Coronavit, is still going ahead, and we will see whether that does ultimately either suggest protection on its own, or perhaps more relevantly in the current scenario, whether vitamin D could boost antibody responses to vaccines. Speaking of which, is there anything I can do to boost effectiveness of my COVID vaccine? Another question we commonly get asked. So looking at antibody responses after vaccination, we see that there are better, stronger antibody responses with people who had Pfizer or Moderna versus AstraZeneca as their first course of vaccination. We also saw that people who had 3 months in between their first and second dose had the optimum antibody response. And when that interval was shortened either to 2 months or 3 to 4 weeks, the antibody response afterwards was slightly less high. We also know that people who had SARS-CoV-2 infection or COVID before their vaccine end up with a higher antibody response afterwards. And intriguingly, people who have a higher body mass index, that is people who are overweight, or people who are Black or Asian ethnic origin, we're seeing stronger antibody responses in those groups compared to people who are not overweight or people of white European ethnic origin. So this is kind of interesting development of the story, where we previously showed that having a higher body mass index or being of Black or Asian ethnic origin associated with susceptibility to COVID-19. What we're now seeing in the post-vaccination studies is that these factors actually associate with better response to vaccines as well, independent of any prior COVID-19 infection. Next question. I understand some antibody blood tests do not pick up all types of vaccination response. Is this the case with the antibody test you're using on your study? Well, just to illustrate here what the coronavirus looks like, you can see in green there's the spike antigen or spike protein, and in light blue the nucleocapsid protein, which encloses the genetic material of the virus. So the test that we use is an antibody to the green or spike glycoprotein, and all of the major vaccines in current use are designed to generate antibodies to this protein. So our test should pick up responses to all of them, and our test can't distinguish between someone who's had natural SARS-CoV-2 infection and somebody who's been vaccinated. So a similar question, can you confirm the test was an anti-S type rather than an anti-N, and what's the difference? So just looking at the illustration again, our test is for antibodies to the spike glycoprotein. It can't tell the difference between someone who's been vaccinated and someone who's been naturally infected. You can also get antibody tests to the nucleocapsid protein or the N antigen, and these tests can distinguish between vaccination and natural infection, and that they're positive after somebody's had an infection with the coronavirus, but they won't become positive after somebody's been vaccinated with any of the major vaccines in current use. Another question, I'm curious to know whether your research indicates any variation in resistance between those who've had the virus and been vaccinated and those who are only vaccinated. And what we've shown in our analysis of breakthrough disease is that if you have COVID-19 and then you're vaccinated, you have a 68% lower chance of getting breakthrough disease than somebody who was vaccinated but didn't have COVID-19 before vaccination. So I hope that information has been helpful and has answered some of your questions. All that remains for me to do now is to sincerely thank you for all of your input and your continued completion of our monthly questionnaires over the last year. The information you've shared with us, I hope I've shown in the talk today, is generating answers and information that are informing public health policy and also providing scientific insights that will help us to tackle the pandemic in the year ahead. So thanks to all of you. Have a great Christmas break, and I look forward to seeing you again in January. Goodbye.